Okay, so today is going to be 3.1, going around in circles, circumference, connecting area, diameter, and radius. So we're doing two sections today. Both will be page 47. Today is March 14th. It is Pi Day. Can you tell by enthusiasm? All right, 3.1, going around in circles. What is the relationship between diameter, radius, diameter or radius, and the circumference of a circle? Okay, so this is very important information. There's a picture in your textbook as well, but I drew it out because it allowed me to color coordinate some items. So circumference is the distance around. You're measuring the distance around a circle. It's just like the perimeter of a circle, but they get their own special names because they're circles, so we call it circumference. Diameter is a distance across the center, so if I went across the middle, now that does not mean that this could be the diameter, because that's not the middle. The diameter is a distance through the middle of a circle, from end to end, and it is always the longest possible line through a circle. You can't get a line longer than a diameter, and if you do, that means your first one wasn't the diameter. A radius is just half the distance of the diameter. So if I made this line go from here to here instead, that's my radius. That's my radius. Is all the way. It's the same all the way across. It doesn't change. If it looks like it's changing in my video, it's because I probably picked the wrong center, or as I'm moving around, I'm not going around in a perfect circle. Okay. So radius, half the distance of the diameter to radius is one diameter. Okay. Yes, draw this. It's very important that you know what items we're talking about. And I'm going to use these words very, very freely in our discussion. So when we start talking and discussing, and you're like, what is he talking about? You need to know these items, okay? This is the lab sheet that will be handed out in class, next class. Now, if you want to get a little bit ahead so you don't have to cut and glue any items, you can go ahead and write this into your notebook. It's only 4 columns and 4 rows. The first row being these titles. So we're gonna find 3 objects in class, and I probably have a few more. I'll hand them out in class, and we're gonna list our 3 objects. We'll measure the diameters, we'll measure the circumferences of each one, and then we're gonna compare these 2 numbers together. Now, if you look at the question, it says, what is the relationship between diameter and radius, or radius? But radius isn't here, because radius is just going to be half the diameter. We kind of assume that whatever the relationship is with circumference and diameter, it'll be double whatever it is for radius, because radius is half the size of the other. In your summary, I suggest that you make a prediction. Okay, so what do you think is the significance? What is significant about the ratio of circumference to diameter? So right here in 3.1, the ratio of circumference to diameter, in your notes, okay, in your summary, or you can write it on this page, you can write a prediction. The ratio of circumference to diameter will be something. It'll be something interesting. What do you think it'll be? And if I measure 3 different objects, will it be the same for each one? Okay, I'm going to type out a couple questions here to guide your thinking and to guide our discussion next class. So we're going to go ahead and write these down. So we should be able to answer these questions by the end of our lesson on Tuesday when I see you guys. So if you know the diameter, can you find the circumference, and how would you do it? How would you find the diameter if given the circumference, and vice versa? So not only can you, and how would you do it? Okay, we'll answer these questions after we finish our discovery activity. Most of you guys like to call them experiments. It's just our activity for class. It's just a math version of experiments. Explain the importance of the ratio of circumference to diameter. So why is that important to know? Or why do you think it's important? Okay. So go ahead and copy this down. It's not a lot, just a couple of vocabulary words, and for those of you guys with neat, nice handwriting, maybe the table. 3.2, I kept this picture here because, again, I'm going to use these words freely. I'm not rewriting them. You don't need to either. But these questions, these words will be extremely important in even understanding the question. So if you don't know these words, most questions will not make sense to you. It'll be very, very difficult. So 3.2, connecting area, diameter, and radius. We're going to connect the area of a circle, the diameter of a circle, and the radius. What things are unique about those three things together? So we need to find a relationship of those items. This is on the same lab sheet. I'll show you what it looks like. Your lab sheet looks like this. 3.1, 3.2, and 3.3, they'll all be on the same page. So 3.1, 3.2, 3.3. You'll pick this up inside the next class. You don't have to draw this one, okay? But if you would like to make the table early, you may. Okay, I know this is pizza measurements. You could just call them circle measurements. We're not measuring pizza because they give you generic size pizzas. So I'm actually going to cover this so it doesn't confuse you. We're just going to do circle measurements because that makes more sense. Even though it's not quite as delicious as pizza, it just makes more sense. So we're going to be doing circle measurements. Oops, spelled that wrong. So circle measurements, small, medium, and large circle, the diameter, the radius, and area. Now, I would start listing these because it'll save us a ton of time in class. So go ahead and freeze the video now. You're counting three things: the diameter, the distance across the middle. The radius is just half of whatever that first number was. And then the area. Now looking at this video, I'm going to zoom in a little bit so you can see it a little clearer. What you're going to do is you're going to count the amount of circles in squares in each circle. And you're going to have to approximate some of them. So when you look at this, I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. You're going to count how many circles you see in the small one. Okay, make a list of it. This one is almost a full square, but not quite. Maybe this one and this one together make a full square. This one and this one make together a full square. Okay, you can make an estimation, but I do want you to make a count so we can save some time in class and we can have a richer, more engaging discussion. If you don't have these numbers ready to go, then we're gonna be behind as a class, and we're gonna lose out on a lot of good educational discussions. So count as many squares as you can. If it's like a half square, like this one and this one, maybe together they make a full square. So count how many squares you see in the small one. Make a quick little list, small, medium, large, and we'll find the area, the diameter, and the radius. Okay, so three things: diameter, radius, and area of the small, medium, and large circles. Again, I'm going to zoom back into these so you can freeze the video. Okay, so there's the small one and the medium one. You can go ahead and freeze those two in place. And here's the large circle. There's a large circle. Go ahead and freeze that in place so that way you can count how many squares you see. Okay. Actually, you know what I'll do? I'm gonna post a PDF version of this lab sheet online in case a few of you guys at home want to print out and cut out these lab sheets early so we can save some time in class, save a little mess. You can go ahead and cut and glue these into your notebook. Okay, we're going to do this discovery experiment in class, so these items should be ready to go. Okay. Now your summary is going to be a little bit trickier because we didn't do a lot of notes. A lot of the discovery takes place in class, but at least we save some time on copying these notes down. Okay, so summary. what is this investigation about? What do you think it's about? Even if you don't know what it is, because we didn't get to any definitive answers, you can definitely make predictions. Briefly describe what circumference, diameter, and radius are, because those are extremely important. And what do you think is significant about the ratio of circumference to diameter? So I mentioned that in 3.1. And what is that ratio, and why is it important? Questions for clarification. Um, Not too much going on here, but I mean, if you have anything that I mentioned that wasn't completely clear, we can review it in class. If you don't have any questions, what do you think a common question might be? And again, create your own math quiz question, test question. What do you think might be on the test? What do you think I'm going to be looking for on your notebook check? Probably something like this, because this is very important, or even your summary and your question sections. Okay, I'm going to post a couple links on your homework as well. So again, the lab sheet I'll put on there. I'm going to put the textbook so you can see it. The only problem with the textbook is it talks a lot about pizza, and it gets pretty confusing because they're just talking about different size circles. So if you want to see it, I'll post it. I wouldn't read too much into the pizza part because it gets confusing again. Just circles. And I'm going to post a video about a book that is very good for what we're going to cover. If you want to watch it, it's a very interesting read. You don't have to. We're probably going to watch it in class anyway. So have your notes ready to go. Again, we have going around in circles, connecting area, diameter, and radius.